Okay, welcome back. And so today we're going to talk about stretches and compressions. Okay, so what are those? Well, now we're going to start talking about when we multiply by a. So now we're going to look at the coefficient. And this is where a comes in. Okay, now, so in the general form we have f of x equals a times b to the x. And now we're going to focus on a because when we multiply outside the function, right? So we're outside the exponential function here. When we multiply outside the function by a constant, it's going to be end up being a vertical stretch or a vertical compression. Okay, so what does that mean? Well, let me show you. So here's our f of x 2 to the x, right? So what happens if I take this function and I multiply it by a constant? Well, let's see here. Let's do 3, right? So I'm going to take g of x equal to 3 times 2 to the x. So what's going on here? I'm outside the function, which means everything that I'm doing is affecting the y values. So I'm taking all of the y values of f of x and I'm tripling them. So that means I'm going to take all of the y values of these 3 points and I'm going to multiply them by 3. Okay? So again, let me just write out the 3 points that the basic function goes through. It's going to be negative 1, 1/2, 0, 1, and 1, 2. Now, if I multiply all of the y values of those coordinates, all the y coordinates by 3, what do I get? Well, I'm going to get negative 1, right? Negative 1, 1.5. This is going to be 0, 3. And this one's going to become 1, 6. Okay? And so now what happens? Well, this point is going to go up to 1.5, so that's going to go to here. This is going to go up to 3. And this one's going to go up to 6, way up here. So what is this going to look like? Well, g of x is going to end up looking like this. So what happened is this graph here of f of x got stretched in the vertical direction. Okay, now, what if we multiply by 1/3? So let's take h of x, and we're going to say that, hey, let's make that equal to 1/3 times 2 to the x. Well, now we're taking all the y values in these 3 coordinates, right? Well, actually, all of the y values on the whole graph are being multiplied, right? But I'm taking these 3 points because those are the common points we've talked about. So all of the y values are going to be multiplied by 1/3, or divided by 3 if you want to think of it that way. Okay? So I'm going to multiply all of the y values by 1/3. Well, that means what's going to happen? Well, now these 3 points here are now going to go to what? It's going to be negative 1, now I'm going to multiply by 1/3, so that's going to be 1/6. And this is going to be 0, 1/3. And then this is going to be 1, 2/3. So now what happens? Well, now this point is going from 1/2 to 1/6. So that's going like way down here, closer to the x-axis. This is going to 1/3, so this is going from 1 to 1/3. And this is going from 2 to 2/3. And so this is going to look something like this. So when you multiplied by 1/3, it took f of x and it compressed it down closer to the x-axis. So what does this tell you? Well, this tells you that if you multiply by a, and a is bigger than 1, then you're going to end up with a vertical stretch. If you multiply by a and a is less than 1 but bigger than 0, then you're going to get a vertical compression. And that's it. So there's an example for you. Okay, so I think that was it. Now, of course, the horizontal asymptote doesn't change. The range and the domain still stay the same. Okay, but again, make sure, look at these three functions. The intercept, the y-intercept changes, right? So look at what changes and look at what doesn't change when it comes to the characteristics of the function. Okay? Have a great day.